Internet and welcome to a new episode on my DIY channel. This is the second part of a video of a journey into FreeCAD. FreeCAD is an open source and free to use 3D modeling software which offers a wide variety of functions and support for 3D modeling. If you missed the first part of this video, I will add a link here so that you have everything together. But enough of the words, let's continue with our modeling process. We will finalize the base part and then go over to model this slider object, prepare everything for 3D printing, and then we will prepare the mesh model, put everything into the slicer program, prepare everything for 3D printing, print it out on a 3D printer, and finally we'll do a proof of concept in the workshop. Here a short 30-second time lapse to see where we are so far. Keep in mind, this is more a step-by-step showcase and not a tutorial, with the goal to show what it means to use FreeCAD for a specific use case, from modeling, post-modeling preparation over to 3D printing until the final product. First I created the base sketch for the jig and used the pad function in part design. Then I created a sketch for the metal insert and used the hole function also in the part design workbench. And finally I created the round groove on the inner side using the rotate groove function in part design. So this is where we are so far. Let's have a look how we continue. Stay curious and let's have a look into the individual steps of modeling with FreeCAD. To create the upper rounded part of the slider object, I wanted to use the revolve function, and therefore I have to reorientate the sketch using the XZ plane as a reference. As you can see here, now I rotated it by 90 degrees. Now I can use this sketch in combination with the revolve function to create the upper rounded part, and I will revolve this 2D geometry by 180 degrees around the Z-axis. Make sure you select the body first and then select the sketch and use the revolve function in the part design workbench. Starting from the sketch, I have to revolve by 180 degrees. An additional result of the revolve operation is that we now have a new horizontal surface that we can use for extrusion. We will now use this new created body in combination with the Boolean operation to cut out a slot for the slider object. As you can see here, I used the Boolean operation in the part design workbench, and therefore I selected the body of the base part and used the new created body as a cutting object. Now it's time to create this slider part. The slider holds the turning chisel and it needs to slide through the slot that we created. Because we cannot have two independent objects in one body, we have to create a new body. The construction process for the slider object or slider part itself is very similar to the construction process that we used for the Boolean operation object. After we created the body, we can copy the groove sketch geometry to the new body. Again, we have to eliminate all the links to the old object. We're just interested in the geometry, and as a next step we're going to make the object a little bit smaller so that it fits into the slot. But the rest of the process is very similar to the construction process that we used with the Boolean object. Again, we will use the revolve function and then using the new created surface to extrude the rest of the body. So what's left is that we create the pockets into the slider part, and therefore we create a datum plane on the top surface of the slider and use this new datum plane as a reference for a new sketch that we have to create. Again, we use the process that we described before. First, we design our 2D geometry with the sketcher tool. Additionally, we can use supporting geometry from the existing 3D model or create new design geometry. Then we can define the constraints and start with the geometric constraints. Finally, we use the distance and radius constraints to have no remaining degrees of freedom in the drawing. After cleaning up the degrees of freedom in the sketch, I go back to the part design workbench. Here I can now use the pocket function to get the opening for the turning chisel. All that is left to do now is to round the edges a little bit by using the fillet function of the part design workbench. Select the individual edges and assign a fillet or a chamfer if you like, as necessary. These steps should be done at the very end of the modeling, and some caution is required here. In the current version, FreeCAD has a bad habit of renaming surfaces or geometry elements in certain situations, and this can lead to a number of errors later on. And of course, don't forget to save in between. It's always good to know that you have a previous version as a backup. Now I unhide the remaining parts in the tree view using the spacebar. I select the base part of the jig model and select surfaces to assign my fillets. This way I can set the fillet to all edges that are related to the surface. And that's a big time saver. What we have so far is a 3D model which is calculated by FreeCAD from different sketches, modeling operations and parameters. In the end, it is a collection of mathematical functions and parameters. What we need is a 3D surface model, or better, mesh model, a three-dimensional shell that describes our object. I let FreeCAD calculate this mesh model in the mesh model workbench and save it as a STL file. To generate a mesh model, there are different algorithms and parameters available for the calculations of the mesh model, so that the result can be improved depending on the complexity and the type of the underlying parametric 3D model. I will use the default setting as this is sufficient for my application. I select each body in the tree view and let the mesh model be calculated. Then I save the file with the export function as STL file. I then load the STL files into my slicer program, which is currently Cura, and convert this information into instructions for the 3D printer. I save this as a G-code file and load them into the 3D printer of my choice. Here I use the Creality CR10 S4, which creates very nice results. It is a very versatile and reliable printer, a little bit slow, but of course it is not designed for the highest speed because of its size. Here at the end, the result of my efforts and the further processing steps. I heat the metal insert to the required temperature so that it melts the PLA Plus material that I used for printing. I then screwed the metal insert into the hole with little pressure and made sure that the insert is screwed in at a 90-degree angle to the reference surface. Unfortunately, I made the hole for the metal insert a bit too narrow. Next time I would add 0.2 millimeters starting from the core diameter of the thread instead of subtracting it. And finally, here is how it came out overall. Basically, everything works as intended and the result is satisfying. What still needs to be improved is that the hole for the insert has to be a bit bigger and the jig should be a bit thicker and bigger overall to fit other turning chisels. The slider itself should have a wider contact to the surface of the chisel, so I have to go back to the drawing table and change the size overall a little bit of the individual pieces. That's it for today. There will be an own video about metal inserts soon. Also, the print preparation out of FreeCAD is a bit short here in this video, but I wanted to show the overall process, so the process as a whole, so that you can better estimate the use of FreeCAD for these use cases and applications. That's it for today. I'm happy to answer your questions about the individual steps using FreeCAD, 3D printing or modeling. Of course, if you have points to add or any constructive criticism, leave me a note in the comments. Keep in mind, to create this video was a lot of effort, and if it was helpful to you, leave me a like and subscribe to my channel. So all the best from my side and good luck in your projects. Thanks for watching. Bye. FreeCAD.